Alright, here we go with section 1.1. Our very first chapter of Integrated Math 1 starts off with a section called Basic Operations with Integers. Now, I guess really quick, might as well address this word integers a little bit. Pretty soon in a future section, we're actually going to officially get into what integers are and other definitions of words, just like integers. But for right now, just kind of you can realize that all the numbers you see here on this number line are integers. -10, even the negatives. -10's an integer, -4's an integer, +6, +8. All these numbers you see here are integers. Now, I don't want to go too deep down this rabbit hole right now, but you probably already know that the numbers you see here aren't the only numbers on a number line, 4.5, or 4.5. That's technically on the number line. It's just not, typed here on this like scale here the way we usually label number lines, like a blank number line, right? A number line graph. But the numbers you literally are looking at, these are all integers. Again, even the negatives. And as you also already know, number lines keep going forever to the right and forever to the left. -11, -12, -13, and so on and so forth. +11, +12, yada, yada, yada. Anyway, so enough about just this one single word in the title. We're doing basic operations. So we're starting off basic. All right? And as we look ahead a little bit, I don't know if you've scanned over this handout and what we're going to be doing in this section, in this lesson, but you can see the kind of basic operations and the type of problems we're just going to be reviewing today. And I guess what I want to say before we really get down to business is that in this course, I will pretty much never deny you the use of a calculator. There's never going to be like a big test that I say like, nope, no calculators allowed. You'll always basically be, again, at least on like official tests and things like that, like really important assessments, you're never going to be denied use of a calculator. You always have a calculator. And on that note, what I'll probably say a dozen or times over the course of this semester is that it's better to be correct than what? Let me put it this way, actually. If there's any doubt, again, looking over the problems we're doing, whenever you have to do these basic operations, like a multiplication problem or a basic addition problem or a subtraction problem, if you are not 100% sure that you know what the answer is in your head, you need to grab a calculator. It's better to be correct than arrogant and try to do it without a calculator, okay? Something else along those lines is this. So whether or not you grab a calculator, I mean, look, I have to grab a calculator at times. It's not like I can do every single, multiplication or division or addition problem in my head, even when we're just using like nice integers. There's times I have to grab a calculator. The fact is that everyone has their own like limit of what they can do in their head. I mean, I like to think my limit is a little bit higher than most students I teach, I guess. But some of these, like I can do all these in my head, for example. But trust me, it gets to a point, like 12 times 13. I don't know if I could, just uh, give that answer in the first like 5 seconds, or 14 times 12 or 11 times 15. Like, trust me, it gets to a point where I need a calculator. And if you need to grab a calculator for, 6 times 8 or 7 times 8 or 9 times 7 or whatever, I mean, that's fine. Again, it's better to be correct than to try to do it in your head because, I don't know, you think it's something I expect. Like, I don't expect it. But on the other side of the coin, I also want to say this. The higher your limit is of mental math, you're just going to be better off. Okay, just trust me on that for now. Even though you'll always be allowed to have a calculator, I think it's if you're not good with like your mental math facts, your times table facts, some all these like addition facts, being able to kind of add and subtract in your head, it's something I think you want to try to get better at because, again, trust me, you're just going to be at an advantage being able to 100% confidently do a lot of this stuff in your head versus needing to pause and grab a calculator. Okay? So moving on here, all right? When you are adding and subtracting negative numbers, think of money. So that's a little piece of advice that some teachers might give you when working with both positive integers and negative integers. All right? So like, I mean, what does that kind of mean? It means like if you have negative $4, for example, I mean, what does that really mean to have negative $4? I mean, that kind of means like you're $4 in debt. It's like you owe someone else $4 before you can even get back to having $0 for yourself. You know what I mean? So we might keep circling back to this whole example of money and how, like if you had $10 and for some reason like you lost $15 in the stock market or on a bet or something, you have $10 and you lose or you subtract $15, like doesn't that mean you're now like $5 in debt? Like you have negative $5 now. If you had 10 and you lose 15, I mean, think of it this way. If maybe I'll take it a step further to help you out, right? If you have $10 and you do like, or it doesn't need to be dollars. Let's get off of dollars for a second. If you went to like a, I don't know, like how old would a student be that's just learning adding and subtracting? Like first grade or second grade? I don't even know for sure. But let's say you went to like a second grader or maybe a first grader. Like you went up to some first grader or maybe someone in kindergarten and you were like, hey, little Timmy, little kindergartner Timmy, if you have 4 apples and you do 4 minus 1, what is that? And if someone's in kindergarten or first grade, they might say 4 minus 1 is, 3. Okay, Timmy, but what's 4 minus 2? And 4 minus 2 is 2. And if you said, hey, Timmy, but what about 4 minus 3? And, Timmy might say 4 minus 3 is 1. And okay, how about 4 minus 4? And if Timmy's really sharp, he would say that 4 minus 4 is 0. But then, if you're talking to like a kindergartner or a first grader or something, what if you all of a sudden rock his world and say like, okay, but what's 4 minus 5? If 4 minus 4 is 0, then what the heck is 4 minus 5? And of course, like you probably know at your age that 4 minus 5 gets you into negative land. All right? and you end up with like -1, right? So, okay. I guess something else to mention here before we just kind of like bang these out, these example problems and whatnot, is like when you're subtracting, like if the operation is subtraction, that generally means like it implies moving left on the number line, If you have 4 and you're doing 4 minus 1, subtraction means you're moving to the left 1 to get to 3. Just like, what I just talked about doing, if you're doing 4 and you start with 4 and you minus 5, minus or subtraction implies moving to the left. Moving to the left, 1, 2, 3, 4, 5, and you end up with -1. Just like adding, the operation of adding generally implies moving to the right on the number line. If you are doing 4 plus 2, that generally means you're moving to the right 1, 2 to land at 6. So just some really quick random thoughts and comments and tips on like adding and subtracting with negative numbers. But anyway, let's really get into things. So here we go. Speaking of like kindergarten or first grade, if you're doing like 3 plus 4, you're going to know that's 7. Well, think of it this way. 3 and you're adding 4, and so that means going to the right on the number line. 1, 2, 3, 4. So it's just kind of like reinforcement of something you knew in kindergarten or first grade. 3 plus 4 is 7. But this is where you might start to get into a little bit of trouble, -3 plus 4. Well, again, it helps to think of a number line where if you're starting at -3, and again, if you have -3 and you're like, again, you can think of like having like -$3, like you're $3 in the hole, like you're in debt $3. And if you add to that, you're moving to the right. Like think of it this way. If you were -$3 in debt or $3 in debt and you gained $3, all that would do is get you back to 0. Because again, on the number line, adding is like moving to the right. But here, it's -3 plus 4. So that gets us 1, 2, 3, 4. Now we're $1 to the good, So that is 1. All right. And here, again, next one, 3 plus a -4. Well, I hope I have something behind here that I'm thinking of. Because something you might remember from elementary school or whatever, adding a negative is just, I don't know, a more extended way to say, okay, I think it is here. What's a shorter way to say 3 plus a -4? That, So just saying 3 minus 4 is exactly the same as saying 3 plus a negative. So, in other words, not to repeat myself, here too much, but adding a negative is literally the same as just subtracting. And I absolutely prefer just saying this. I don't like writing things out like plus a -4. I just don't like it. So my brain definitely, and the things I write down on the board or on paper, I just go right to subtraction rather than adding a negative. So what is 3 minus 4? You're starting at 3 and you're subtracting 4. Well, that gets you into negative land at -1. Again, think of a number line. 3, and then you're subtracting 4. 1, 2, 3, 4. And then a -3 plus a -4. Once again, that's just like saying -3 minus 4. Adding a negative is just like subtracting. And again, think of it like you're already at -3 on the number line, and you're subtracting 4. That gets you even deeper into negative land, and that lands you at -7 on the number line, for example. So there you go. Like if you're doing this on your own at home because you missed class or whatever, please pause the video and try these on your own, because I'm going to just go through these answers in 5, pause the video, 4, 3, 2, 1. All right, if you pause the video, you've unpaused, and here we go. 9 plus 2 should be 11. -9 plus 2, that ends up being -7. And then this is just like 9 minus 2. Again, adding a -2 is the same as just subtracting 2. And that's +7. But -9 minus 2, again, you're already at -9 and you're subtracting 2. That gets you to -11. So speaking of videos, I mean, if I'm going too fast for you there, again, you can always pause the video so you can copy things down, so I don't move on without you. Subtracting. Again, I mean, just to kind of, again, repeating myself, but subtracting is just like adding a negative, so more the same, I think, from before. So +3, but if you subtract 6 from +3, once again, if you're at 3 and you subtract 6, that's moving to the left 6 spaces. Like I said a few minutes ago, it's like if you did 3 minus 3, you'd get back down to 0. So what's 3 minus 6? Well, it gets you into negative land to -3. Well, here you're already in negative land. -3 minus 6, -9. Here's something. What does it mean to subtract a negative number? Right? Again, before it's like adding a negative. That's just basically subtraction. But what does it mean to subtract a negative? Well, that means just adding. So a double negative here means adding, right? And again, just like I kind of said a minute ago, with this type of stuff, I do not like writing or talking about minusing a negative. I just like, it's adding to me, okay? So maybe you like that and you're fine with that. I very quickly just want to make it 3 plus 6, which is of course 9. And so -3 minus a -6, you might as well write just -3 plus 6. A plus sign takes the place of the minus a negative. And then what's -3? Adding 6. If you're at -3 on the number line and you add 6, where does that get you? Well, again, if you had -3 and you were adding 3 to that, that would get you back to 0, but we're adding 6. So that gets us to 3. And then just like before, if you're doing this on your own at home, you should pause the video before and do this on your own before unpausing. So I'm going to bang these out in 5, 4, 3, 2, 1. 9 minus 1, 8. -9 minus 1, that's -10. And then 9 minus a -1, that's just like saying 9 plus 1, which is of course 10. Again, this just becomes like a kindergarten or first grade question once you simplify it, so to speak. And then -9 minus a -1, that's like -9 plus 1, which is -8. Okay? Now in class, this is where we would kind of pause, my lecture. We would pause note-taking to have you guys fill out your times table chart. So hopefully if you're at home, you have this handout, this paper with you, and you're going to want to fill this out at this time. All right? And again, like I hope you should try this without a calculator. You know, do every single thing you can without a calculator, right? Like 2, so this spot right here is obviously 2 times 3. All right? So just a freebie here. So this box would be 3 times 2, which of course is also 6, right? But this is how this kind of works, okay? And again, try to fill this out without using a calculator. Like I said at the beginning of this video, it is to your advantage. Like the more times table multiplication facts you have memorized, the better off you are. All right? So do this really quick before unpausing the video and moving on with me, okay? But now that you've done that, time to move on to some review, some reminders about multiplying and dividing when you are using, potentially, negative numbers. For right now, just integers. So, just some facts that you should already be aware of from a previous math class. If you are multiplying or dividing two positive numbers, like positive 3 times positive 8, or positive 10 divided by positive 2, the answer will be positive. But if you are working with a negative number and a positive number, you know, like negative 2 times positive 8, or negative 25 divided by positive 5, you'd end up with a negative. Again, these are just rules that you are probably remember from before. And so here it'd be a negative, positive number and a negative number, and two negative numbers when you're working with two negatives with multiplying or dividing. So, yeah, you remember this, right? When the signs, so you might have heard it this way. When the signs are the same, like this, okay, right? When the signs are the same, your answer is positive. But when the signs are different, like here, like so, your answer is negative. So, final stretch. Again, so this is like combining, hopefully, your knowledge of your times table facts, and hopefully, as many of them memorized as possible. Just combine that, like your times table facts, with, if it's like with negatives or whatever. So, positive 5 times positive 3, that makes positive 15. Negative 7 times a positive 8, that gives you a negative 56. When the signs are different, it's negative. Again, signs are different, so this answer is going to be negative, and is it negative 36? And then a negative 6 times a negative 8, that'll make a positive, right? Positive 48. And a quick note is, like, I hope you already have previous knowledge of that symbol being used for multiplication. This is a very, 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 very common symbol for multiplying, right? Now that you're in high school, it's more common than the X for multiplying. But you probably already knew that. Last 4 examples, I believe. Oh yeah, last 4 examples. Just dividing, and again, dividing is what? It's like the opposite of multiplying. So if you're really good with your multiplication facts, your times table facts, dividing is just kind of like the opposite. So you should also be kind of strong with dividing at the same time. They go hand in hand, is what I'm saying here. And the rules about two negatives or two positives, or when the signs are different, still apply here, just like I already said. But a negative 36 divided by a positive 6, that'll be a positive, oh my God, wow, I don't know why I said that. Whew. Yeah, it's been been a long lesson, right? How long has this been? I don't know how many minutes, but sorry, negative 6. A negative divided by a positive is negative 6. A positive 40 divided by a positive 8, that's going to be a positive 5. I will not make any more mistakes. So here we go. A negative 21 divided by a negative 3, that's going to be a positive, right? Two negatives make a positive, positive 7. But here the answer is going to be negative because we have a positive 42 divided by a negative 7. So that's going to be negative what? Negative 6. And I believe that's it. And yeah, so just in case you forgot, like some of the tidbits from the beginning, just to kind of bring this lesson full circle. Remember about how I will never deny you use of a calculator. Please, please always use a calculator for these type of like simple operations. If there's any doubt in your head of what the answer is, okay? Don't be wrong, okay? Grab a calculator if you're not 1,000% sure what the answer is, okay? Better to be right than wrong, obviously. No shame, because like I said, everyone has their own limits of what they can do in their head. I have my own limit of what I can do in my head, just like you do, okay? And but final comment is you do want to try to make that limit a little bit higher. Like you do want to work to have like more mental math facts memorized, okay? Like I said, trust me for now, but you do have an advantage, and it is better to know like all of these. I would say it's not too much to ask to know all these answers in your head, or all these answers in your head, or all of these answers in your head. You know what I mean? But anyway, that's it for lesson 1-1.